So we can just go on, because I don't have to introduce myself this time. Yeah, second part is about grounding solutions. Like I said before, it's been a while, so I will also talk about different parts of our grounding solutions and pick out the USPs and talk about our philosophy, how we think about these products, and why we are choosing to have these kind of products. Yeah, the base is still our 6-point protection plan. But now we're not going at the top, but we're going down into the earth. This picture I also showed you before. And we're now going to talk about the part that is on top, the grounding installations, so all the products that we have in our portfolio for grounding, for a decent grounding installation. And a little bit on cat-weld exothermic connections. First of all, why grounding? Sometimes I say to our sales team, we are selling fear. Because what we want is to have the protection of people and equipment, and also for buildings. So if people want to protect their property, but also their lives, they also need a good grounding system. And of course, what we have seen in the previous presentation, it's for the lightning dissipation, to follow the path through the earthing system and to have a sufficient grounding system that works. How do we do it? Well, this is really a basic picture. It's maybe a product that you don't know very well here in Europe. We don't sell this a lot in Europe. It's called a hammerlock, and it's a different kind of connecting the ground rods with the physical electrical installation. And that's just the meaning of grounding. If you look at what we call the grounding system, of the grounding chain, when we see several parts, first you have the physical earth. And we all know that this earth can be very different. It can be sand, it can be mud, it can be rocky. So depending on the type of soil, you also have to adapt your grounding installation. Our GEM, our ground enhancement material, can help with that. And of course, you need to use a high quality ground rod. You can connect it with cat-weld, you see later on. And of course, the conductor needs to be fine to have a good earthing system. First, a bit on GEM. If the resistivity of the soil is not good enough, then we can use this material to improve it. We dig a hole, we throw the GEM inside, pour some water on it, and it becomes some kind of a cement. In that case, we can improve the resistivity. It also helps the ground rod from corrosion. And there are even people who say that it's an anti-theft thing, but that is maybe a little bit far. One of the characteristics of our GEM, and that is well recognized all over the world, is that we have a very high quality and a material that has a resistivity factor that is much higher than most of the products on what we can find on the market. That means that if you need this material to improve, and you need less GEM than other products that you can find on the market. And the difference can be quite significant. Another part, I think also a very important part of the grounding system, is of course the ground rod. We are promoting a lot our copper bonded ground rods. Worldwide, we are the biggest manufacturer of these type of rods. We have a factory in the US where they produce a little bit more than 20 million pieces every year. One of the characteristics of this product is that it's a high quality product. Well, what does it mean? We're using high quality steel. You know that if you're driving a ground rod into the ground, it will never go in a straight way because there are rocks, there are different types of soil, so sometimes a ground rod will bend. Well, and if you get this situation, when it bends and it cracks, then there is a point of failure, so to say. Another thing, and here you can see the different lifetime expectations of the different type of rods. So for a galvanized rod, it's only 15 years. So that means that after 15 years, normally you should replace the complete earthing installation because you cannot guarantee that it will last any longer, depending, of course, a little bit on the type of soil. In our copper bonded ground rod, we have two versions: the standard one for 35 years, and one with a thicker layer of copper around that goes up to 45 years. And compared with stainless steel, that's just a little gap. If you're designing a building, normally what will be the lifetime expectation of a building? Maybe 40 years maximum. So next to the copper bonded ground rods, we also have other type of ground rods. Before the break, I already explained that there are different habits and different standards all over the place in Europe. So we need to adapt our offer on that. But one of the things is that we go for our quality of our copper bonded ground rods. That there is a lot of material on the market that has a lower quality. Has to do also with the way we are manufacturing this ground rod. We can guarantee that along the whole length of our ground rod, the thickness of the copper is everywhere the same. That's due to the process that we have. It's a long line of more than almost 100 meters that we have, and the rods are going through it as a long cable, and after that we are cutting. As where we see that, for example, rack dipping, the thickness of the copper is not always the same thickness. We do a lot of testing, and if we are testing other copper bonded ground rods, there are that meet the standard, but there are a lot that don't meet the standard. And the biggest issue is that the continuity of the thickness is not the same. And that's the same for jacketing and cladding. It's another type of producing, but it can cause problems, especially if you're driving into the ground rod, you're touching a rock, you can have that the copper is completely gone at the side of your ground rod, and then you cannot guarantee the lifetime expectations. Second part, and catwalk is, like I always used to say, the DNA of ERICO. It started more than 100 years ago with Mr. Catwalk, and he invented the exothermic welding, and it was used in the rail applications. It was to make the connection, the bonding between two parts of a rail. That system has evaluated up till the system that it is now, where you can see the molds made out of graphite. We make them in Tilburg, in the Netherlands. There's cleaning material, because this mold can be used more than 50 times if you're cleaning it in a proper way. And we are using let's say, an espresso type of cup where the weld metal is in. Before there was the traditional weld metal, and it was you had to pour it in, and you can imagine that if you're outside and there is a little bit of wind, then there goes your welding material. There is a handle clamp to open and to close the mold, and some personal protection. And that is needed because during the exothermic process, the temperature inside of the mold will rise up to 2,500 degrees Celsius. And you're really melting the copper bar, or the bars or the cables together. And to ignite the process, we have an electronic igniting tool. That's only a matter of pushing the button, and the process will start. Here you can see the situation of a mold with two cables. We have more than 30,000 different types of molds, depending on the size of the cable. Can be a copper or metal, can be flat tape, but we Whoa. Can everybody hear me? Yeah. So this is the mold and the clamp. Here you can see the inside of the mold. And when the cup ignites, it melts, and the melting material goes around the cables. And what you can see then from the outside is this, and from the inside is this. So you can see that the cables are completely melted together. What we always say is that when we have a catwalk connection and two cables, the best part of the cable is the catwalk connection. This, in a schematic way, looks like this. So you have here a completely melted solution, and the current can flow in an easy way through the connection. As well, you have a crimped connection, or even a mechanical connection. That's even worse. There are just a couple of contacts, and so it will be difficult for the current to go through. And you can imagine that it could be, if the crimp is not done well, that there is also a heat spot that can occur. Here's some examples from what's happening in the ground, because like I said, the grounding materials, once it's installed, we put the sand over it and we don't think about it, but it is still there. And here you can see what's happening with the different type of connections. The mechanical connection to photos, and you can imagine that after 10 years, the pressure of the connector is not the same as when it is initially installed. Then we have the crimping connection, which is or a little bit better, but you can see there is some corrosion already inside of the cable. And here we have the catwalk that is a completely closed solution. And yeah, like I said before, it's maybe the best part of the cable. So what's happening into the ground? We don't know until now. Because we have a new device, it's called the Guardian, and it's a power and protective conductor monitoring device. It's a new technology. It's patented. It's for continuously monitoring. That's maybe not the most important part. But you can also, from a distance, see the information of the installation, and it's very easy to install. Now, what is this Guardian? What does it do? It can measure and monitor the loss of a neutral. And I think that if there are installers here in the room, everybody has experience with a loose neutral. If it is a screw that is not tight enough, if it is broken some way, and the damage that it causes is normally quite big. It also measures a broken pen conductor. And we can measure the voltage on the earth or the ground conductor, what's also called stray voltages. And on top of that, we can also measure high and low voltages and high and low frequencies. Talking about these stray voltages, if you have a grounding system, and normally this occurs also with two different grounding systems next to each other, it can be that there is a potential difference between the two systems. And that is something that we see here. Here you can see there is 35 volts on an electric or on a metal pole that's standing on the platform of the train. Well, 35 volts is not yet dangerous, but it's not normal even. How does it work? Here you can see a three-phase system with a pen, and when you can have an open circuit, so a broken pen conductor, or here in this wire, then the current is flowing through the device. An RCD does not detect these kind of problems, and the current is going through the person to the ground, and it can give you some shock. In the Guardian, we're using the open technology, and in general that means that we are creating a virtual neutral, this point in the center of this green circle. So the Guardian creates this virtual neutral, and if there is a problem in the installation, there's a neutral that is broken, then it will shift outside of this circle, and this circle has a value of 70 volts. And why 70 volts? Because we know that at 70 volts it can be deadly for human beings. So if you look at this installation, this technology has been developed for EV chargers in the first place, but it is also working in other installations, of course. Here, if there is a fault, then the fault goes through the installation. The RCD does not detect the fault, but the open module, in this case, detects the fault and can shut off the installation. Well, what is the danger that can occur with a broken neutral? You can get a very high voltage on your line. That means that equipment that is in the installation, what normally works between a certain level of voltage, will get damaged or even completely broken. It can cause fires in some cases, and it can lead to electrocution. So here we see one example of a building where in every sub-distribution board has built in a guardian. If there is a problem in the installation, it will shut off this part and the rest of the building will continue. It's an easy to install product. It's more or less like an SPD, a surge protection device. It can be installed in new build installations, but also for retrofit. So if there is an existing installation that has problems with stray voltages or even a neutral that's falling away, then it can be installed in that way. The only thing you need to do is to have a fuse in the lines of 1 amp to protect the guardian itself. It can be used in different types of networks. So here you have a 3-phase 4-wire system, a 3-phase 3-wire system. So all kinds of systems where it can be used. And here you can see there is integrated in the device 2 relays, and these relays you can are programmable, so you can shut off some of the loads or a part of the loads or just sensitive loads, whatever you want. Like I said before, it is as a remote monitoring. You can connect it to the cloud. It's a cloud-based monitoring. So then all the information in the installation is available. For example, here you can see there are some alarms. And here you can see the line voltages, the neutral voltage, which is already above, that's only 1 volt, which is quite normal. It can be normal in a neutral. And you can also connect the system via Modbus to a building management system to integrate all the information into a bigger installation. It can generate pre-warnings. So if the voltage goes up, but it stays below 70 volt, then it can send out an SMS or email to the person that is responsible for the installation, a facility manager or something like that. And after that, you can, like I said, isolate the loads. There is an installation where we use 2 external contactors in combination with the guardian and 2 relays to shut off a part of the loads depending on where the problem in the installation occurs. Typical applications, and that's maybe a bit strange to see, but milking farms. Cattle is very sensitive for stray voltages. And when you have a stray voltage that is maybe 25, 30 volts, a cow is sensitive for that. And when a cow touches a gate or something with this stray voltage and it will get some kind of shock, then they don't want to return. So you can imagine that a farmer who needs to milk his cattle, but if there is a problem with stray voltage, the cattle don't want to get into the milking machine, and he has a big problem. Another one, what we have seen is in a chicken farm. I don't know how it's here, but in the Netherlands we have chicken farms with 10,000, maybe hundreds of thousands of chickens. And one of the main needs they have is oxygen. So if the ventilation systems will fall down, then immediately after some period of time, they are all killed. Another more typical installation is in marinas and swimming pools. You can imagine that current in combination with water is not a very nice one. And there are some examples of installations between a boat and the shore, where there is a problem in a broken neutral, where people get hurt or even get killed. That are just some very typical situations, but in general, the Guardian, and we're now working with this product for about a couple of months, and we discover every time new applications. The list of applications is big, and sometimes in areas where you don't expect to have it. We have here my colleague Jan Magne from Denmark. He was in a hotel, and he talked to the manager, and the manager said, I have a problem with my electrical installation. And he wasn't even visiting that manager, but he was just staying in the hotel. And by coincidence, he had an appointment with the installer that was working on the maintenance of the building. And she said, every week, we need to go to the hotel because there is a problem with equipment that is broken. Every time there is a TV broken, every time the other parts of the installation are damaged. And there, this application is quite specific, but it's a nice way to see that it can be used everywhere. And you can see here the list of applications is very huge. Conclusion? Well, I think what we've seen, we are a leader in grounding and bonding solutions, and this is the next step. So what goes into the earth now, we can measure it, and we can see if there is a problem. And I think that's a big step forward.
So thank you very much for the presentation. Now we know more. So what else we don't know? Do we have questions in the audience? Still you have some blank spots in no questions? You know now everything about the potentials and protection against that. No questions? Yeah. Oh, there is one question. Yes, I see. Okay.
Maybe one small question about the system where is more than one or two these lightning protection interceptors. Yeah, I was told that these interceptor groundings must be connected with themselves. Can they be connected to the building potential equalization system with the spark gap, or they need to be connected directly? These grounding systems of this each interceptor.
The interceptor for the lightning protection, you mean? Yes, they need to connect all by themselves to the grounding system.
These grounding systems, if they need to be connected mutually?
Not necessarily. It is possible to have a different type of grounding system.
I would say yes, but it depends on the distance in between the grounding systems. If it's two sides of the building, and for example, there are 50 meters in between crow's foot, there is not an obligatory thing to connect them. If they are closer, then it's better also to connect them together. But the connection to other potential equalization systems, it's also mutual thing, so that there is no potential difference. Because what kills everything is the difference in potentials. So spark gap is a good thing to connect them, and if they are more than 20, 50 meters in between those crow's foot, then they cannot be, well, they can be separate without connections. If they are closer, it must be connected, just because of the difference in potentials. Any more questions from the audience? Someone?
Well, we're still here all day, so if you have any questions, my colleagues and I...
Yes, here I see one more question still.
Yeah, question regarding CAD welding.
Yeah.
Just as I understand from the presentation, it was shown that only copper 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 tapes and copper pipes can be CAD welded, or maybe different materials either.
Yeah, also steel.
Also steel.
Yeah.
Basically steel and copper.
Steel and copper, yeah. It's
And-
depending on the welding material that is needed to weld these products together.
Mhm.
So if you have other, we in the past we used to have also welding material for aluminium, but the parts that were in the welding material, it was highly inflammable. So we stopped with that. So we now have only the copper and the metal and the steel connection.
Basically steel, it will be galvanized in stainless steel, right?
Yeah.
Thank you.
It can be done, and it is already been done in Latvia as well.
All over the world.